my name is Lowette. I work as the head of learning and development for Axxes in Belgium, and I'm here at GOTO Amsterdam with Dave Thomas. Dave, can you please introduce yourself to the audience for the people who do not know who you are?
Absolutely. So I am not the go-to Dave Thomas, who was the small talk guy and everything else. I'm Pragmatic Dave Thomas. I've been programming for, more than 50 years now. And I'm the author of the Pragmatic Programmer, a few Ruby books, Elixir books, and one of the creators of the Manifesto for Agile Software Development.
Yeah, that's something you undersigned in the past, and that has changed the software industry for the better, I would argue.
Well, that's nice.
What was that like? Because I grew up in a world where that manifesto was already there, right? I started programming when that already existed. What sparked you guys to think about this and to try to formalize the ideas in the manifesto?
Survival, largely. Back then, in the 90s, software development was a total mess. I mean, the vast majority of projects never came in. And when they did, they were buggy. They didn't do what people wanted. It was just a total disconnect across the process of wanting software and acquiring software. It just didn't work.
Right.
And so people were exploring with different ways of doing it. Back then, the idea was you came up with some kind of requirements and you got those signed off. And then you came up with some kind of architecture, got that signed off, and then a design. And then you would hand it over to the coders. And the theory was that they would go away, do their thing, come back with exactly what you specified. And miraculously, that would then get delivered and work.
Right. And in the meanwhile, obviously, the business could not change because the requirements were signed off months ago.
Well, you tell that to the business. Ultimately, the business did change. It wasn't just that. The thing that surprised people, I don't even think it surprised them because they didn't notice it. But people don't know what they want. And when they came up with requirements, it was at best a guess, you know? Mm-hmm. And so people would invest tens of millions, hundreds of millions producing software that was based on really just like a wet finger in the air. You know,
bad assumptions,
bad understanding of where the value was in the bills, all this kind of stuff. So the thing that a lot of people were looking at was how can we shorten that gap between what we're doing and what's wanted. And there's many ways of doing that. I mean, XP is probably the most famous back then in terms of enforcing a short cycle and lots of feedback. And that is pivotal when it comes to writing software, right?
Especially if you approach software from the angle like we can still change things. When you're building a big skyscraper, that's a lot harder to do.
Right.
But the fact that it's in the word, it's software, right? The fact that we can still change it means that we need to adopt different processes.
Absolutely. It is both the blessing and the curse. Right. It's what makes software exciting to write, but it also is what makes it a pain in the butt, that you do have to change it all the time. It's actually, if you look at it in a slightly different way, I would say that one of the problems of agility is that back then we didn't have this kind of explosion of frameworks and techniques and tools and everything else because we couldn't. I mean, there's no way we could keep up if people were throwing a new framework at us every week. And now that people are looking at shorter life cycles and shorter iterations, then they can start playing with the different framework to see if it works for them. And I think to some extent, the success of that way of writing software is also now become the bane of everybody's life, trying to keep up with all of these changes that we're allowing.
For me, as a .NET developer, I started in a time where Microsoft would release a new Visual Studio every couple of years, and it was shipped on DVDs, and I had time to learn all the new things before the next one came out.
Right.
Those times are long gone. I think it's also very exciting to see that we get also on that side, shorter feedback loops. You actually see the things that are happening in the industry, making it back into the language design, which I would argue is a good thing, but it makes it a lot harder for people to keep up with everything that's happening.
Not just that. I mean, I've been working on something, and I had the freedom to mess around. It was a toy project. So I was playing with React, and then I tried Next, and then I switched across to try Solid, just because I thought it looked kind of cool. And in the end, I bumped into the lack of a library. So I went back to React. And in the time it had taken me to go around that loop, my application no longer worked with that new version of React. Right. So yeah, I mean, it's good, but it's a pain in the butt too. You know, it's the unless you lock down the version of absolutely everything, then you're guaranteed to be out of date within a couple of months, which is scary.
I had a discussion with a customer a few weeks ago where I was writing a proposal for them. They asked me, like, why do you want to use .NET 6? Right. 7 is out already. And I was like, 6 is going to be supported for longer, and we will swap it to 8, and we'll skip the intermediary ones because it's not going to be big revolutions in between. So let's keep some stability for the team and focus on delivering something that you can do something with.
Yep.
Because your customers are not going to care whether it's .NET 6 or 7 or whatever.
Right. And in fact, I think that's actually a really wise move, because we are obsessed with bright, shiny things in this industry, you know?
Yeah, I call it Magpie developer.
Yeah, exactly.
So it's like, new shiny thing. I want to put that on my resume, so I'm going to use it in my project.
Exactly right. Exactly right. And invariably, that makes projects, take twice as long as it should.
Yes. It takes away a lot of the focus from what we're actually there to do. And what I have always felt that the manifesto was about is putting value in the hands of the users, right? Yes. And I would argue that is our entire reason for being as software developers is to deliver something that works, that people can do their jobs with.
I think that's certainly the primary value that we have and the primary reason we have to exist. I think we also have a secondary reason, which is to make ourselves better.
Sure.
And that is the hard one.
But that's the one that rings back to the whole pragmatic programmer, doing coding katas to improve yourself, practice in side projects and not in your day job, that sort of stuff, right?
Yeah. And I think that's still valuable advice. I still do it. I don't. In the old days, I used to try and keep up with everything. Now that's just a recipe for mental breakdown. But I still try to keep up. I still try to try new things. Because
expand your toolbox.
It's not so much expand it as refresh it every now and then. Yeah. So if you've been using the same tool so long that it's really, really comfortable and you kind of worn your fingers into the handle, maybe it's time to think maybe it's a different one.
I love the fact that you mentioned Elixir as well. I'm definitely rooted in the .NET ecosystem.
Right.
But one of the things that made me think completely differently was learning Akka.NET and the actor model, which you have in Elixir as well. Made me think about the whole threading problem from a completely different angle. Mm-hmm. And I always love it when something takes me out of my comfort zone. So learning Java will not change that much because they're very similar languages, but something like an actor model or functional programming, that makes you think about certain problems from a different angle. And then you bring them back even to C#. Like you start applying different patterns in the languages that you're using because you saw something somewhere else.
My first object-oriented programming was in Simula in... I got to get this right. 1974.
Right.
And
I was -8 then.
That makes me feel so good. And I have been doing OO programming. There was a spell when I was doing assembler in C and then other languages. But from the mid-'80s onwards, I've read almost all the programming I'm doing was object-oriented. And I was like, this is the way it has to be. It's just so natural. And I wanted to get into functional and to try it, and I could not find a language that I felt comfortable with. And then I came across Elixir, and it's not a pure functional language, but it has a lot of the things that I thought were wrong about functional languages were in Elixir. The immutability, for example, the lack of control statements. And I discovered that I was wrong, and having spent so many years writing this code, that took me a while to come to that realization. But the realization, actually, yeah, OO has its place. But now, when I write, for example, JavaScript, I almost never write a class. I'm writing my JavaScript as functions and closures and doing it in a very, very much a more functional style.
And that came from learning Elixir?
That initially came from learning Elixir, and then I finally convinced myself to do some Haskell and Reason and a whole bunch of other functional languages. And now I write most of even in JavaScript, I will write most of my code using mutations on immutable data structures because it's easier to reason about.
And it takes away a lot of side effects that you would have from traditional OO programming as well. And
particularly in JavaScript, where it's such a mess. I think it's.
We have a song about that.
It's a good idea, I think, to put some discipline and constraints on yourself.
That's obviously, and I think that teams struggle with that is finding out a way that the whole team works in the same boundaries when you're producing code, especially in modern languages. If you look at like the big mastodons in the programming language world, you can use them in very different ways.
Right.
And I would argue if you apply that functional programming style in a language like C#, that should be a team decision because you want to have the entire code base behave in a similar way. Otherwise, it's going to be quite impossible to onboard new people on projects like that.
Absolutely. I mean, nothing is worse than a team with one evangelist and who says, we have to do it this way. And they all go, no.
I've used the analogy of that particular problem is you build a tree trunk and you can date a certain feature in the code base on the practices that were being applied to build that feature. So we have this front-end framework and this way of structuring the code. It must have been built 2018. Right. And what teams forget is it's okay to change your practices, but you have to hollow out the trunk. Like the old practices need to eventually go so that you have a manageable stack that you can onboard new team members on. Otherwise, that becomes something too painful.
Yeah, and I think the mistake people try to do is to migrate existing code bases. And I think the idea, you were talking about actors and akka and things. Once you start looking at a more distributed, that's not even the right word, decoupled architectures like that, then you can be writing your actors in C#, someone else can be using F#, someone can be using Visual Basic for all I know, right? And
they'll be deployed in the same cluster and talking to each other through messaging.
Right.
Which is what we see on a bigger scale with microservice infrastructure architectures as well. Being made, also that has become easier to do with the modern stuff.
Right.
What future do you see there? Because you already mentioned things are moving fast and they're changing quickly. In the current state of the industry, what are the things that you're really excited about to see where they're going to go?
Immutability is, I think, the next frontier. And by immutability, I mean way more than just data structures that you can't change in a functional language. There are so many problems that go away if once you've done something, you can't change it. It is stunning. For example, if your databases are immutable, then you can think of every single change you make as creating a brand new database.
Okay.
Right? And therefore, if I have the ID of that database, some unique number that identifies that particular database, and pass that around, then that will always be the same. It's an immutable database, right? Which means I don't have to worry about transactions anymore. Right? I do have to worry about merging every now and then, but that's okay. It's constrained by the database. There are so many things that you can do better if you have immutable databases. Even down to the fact of you can do queries backwards in time, because each database is there. And if you have some directory that says, well, yesterday's database was called 123, then I can query 123 and get yesterday's data. It's amazing.
That's one of the things that I've been doing with event sourcing.
Right.
Where you have an append-only log of the things that are happening, and you can go back to a certain point in time. But what you seem to be proposing goes even a step further than that.
Yeah.
You can get like yesterday's snapshot of the entire...
Yeah, but it's no longer a snapshot. It's the reality. It is the database. It just happens to be a different database to the one that someone else is using in today's. And it's one of those things where if you hear...
Is that one of the things that's already brought into practice?
Oh, yeah. Datomic is a database in the closure world, JVM, that is immutable. There's quite a few. Actually, if you look around, there's quite a few immutable databases available to you. But I think that will start to spread a lot more. Particularly, it's really, really good at having local databases that you then have to resolve up into more general global databases. So for edge stuff and things like that, it's just a great technology. But here's the one I think is going to freak people out. Immutable code. So you write code, and the second you make it shareable, either by publishing it or whatever else you do, it becomes immutable. And it cannot be changed, ever. And what happens is that your code becomes known not by its name, but by some unique identifier for the code in that particular state. And all the other code that wants to use that is going to bring it in by that identifier.
Wow.
Which means that you can change your code 50 times a day, totally breaking any interfaces that you created, and nobody else's code will break. Wow. Because they're all using the immutable code. Now, you think, okay, that's going to be impossible to do. And yes, if you're doing it by hand. But there are languages now. The poster child for them is a language called Unison, where they have, it takes it so far that you do not actually have a definitive copy of source code on your local machine. You're editing on your local machine, and there's like an environment in which your code is sitting in your local machine. And you can make changes, and it picks them up and runs them, and then runs the tests and everything else. But at some time, you do effectively a push on your code, at which point it assigns a version number to it. And the cool thing is, the version number is a 512-bit hash of the AST of your code.
Oh, nice.
Right?
So the checksum is built in as well.
The checksum is built from the AST, but the cool thing is the symbol table is not in the AST, right? It's just referenced by, number effectively. So if you were to write a function that said function add AB returns A plus B, and I was to write a function called sum that takes number one, number two, and returns number one plus number two, they have the same AST.
The ASTs are going to be identical, right?
Yeah.
So, which means that even if I write a function that you already wrote, in the end, we will end up using the same
until
function.
One of us makes a change.
And then there's two versions of it.
There's two versions of it, right?
Right.
Even better, you say to yourself, somebody must have written a function that adds two numbers. And you can query it to say, is there an existing function with this signature? And it comes back with the functions, and you say, no, they're not right, or yeah, I'll use that one. And from your code's point of view,
it's never going to change and break your behavior because you're using a specific version.
So what happens is that when you write new code, and if your new code uses sum, then that little runtime environment thing on your machine says sum. Okay, I'm going to go look that up, right? And it knows that sum corresponds to this particular hash.
Right.
So that you see sum, but inside the AST, it's the hash. And then when it saves it up, it's the hash.
So effectively, if you build a product thinking this way, a lot less of the code is going to be unique to your product because you're dragging in things that already exist for whatever matches.
I think ultimately that will be the case. I mean, you can imagine a situation where...
This is dry on steroids, isn't it?
It is. But I think the main thing for me is it stops all my react hell, right, where things break.
Right.
Because I'm always guaranteed. Here's the cool thing about this. Think about deploying your program, right? So you have a piece of code and it maybe uses, well, I don't know, the average JavaScript program probably uses 2,000 to 5,000, right? Separate libraries. So you've got those 2 to 5 separate, all NPM locked somewhere, right? Not anymore. You deploy your main program. That's all you deploy.
And then all the other hashes get pulled in.
All the other hashes get pulled in automatically, and they automatically work because they're automatically compatible with the code that you wrote. So deployment is literally, here's my file.
So left pad issues would no longer occur.
Yeah, I mean, whole industries will go out of business. It'll be great.
Well, that's the thing that a lot of people are scared of for the future is the trained language models that are going to reduce the value of some of the skills that we have today. How do you look at that? Let's end on that.
Okay. We have always worked on making our tools more efficient. And ChatGPT, is basically Stack Overflow with a better interface, right? Developers have always copied other people's code. And they've always gone in there to work out, okay, I have no idea how to do this. So I'll go through GitHub and I'll find someone else that's done it and work it out, you know? So it's a more efficient way of doing that. I personally use Copilot a lot for repetitive stuff. So if I'm filling in some test data and I need like name Dave, after about 2 lines, it works out what I'm doing and fills the rest in for me. I love you.
But that is the code that you don't care about crafting or writing or whatever anyway. Because it's the repetitive task. You want to already move on in your head to the next task that you're going to need to do.
Which is exactly why I like it. Yeah. But I think in reality...
So you're not scared for jobs just quite yet?
I think that there is a class of developer who could easily be replaced. Because I think there's a class of developer that really has never learnt how to code and survives with copy and paste and, good excuses. I think that the time of I don't think you will go to ChatGPT and say, write me a payroll system. That's not going to happen anytime soon. But I think that you couldn't go to those copy-paste developers and say that either, right?
Right.
So I think what you're going to do is say, what differentiates me from something that is really, really good at searching for existing answers to solutions? And the answer is finding better answers, right? If all we do is have ChatGPT writing code for us, and if that ChatGPT then trains itself on the code that it wrote, well, I mean, that's just regressive. I mean, we're going to end up back with, 10 print hello if we're not careful. So I think there's always going to be room for developers adding humanity and adding creativity. Let's put it that way. But I think to do that, you've got to be consciously making yourself better.
I think that's a great message to end this talk on.
Well, there you go.
So thank you very much for being here. I hope you enjoyed the talk. Look up the stuff that Dave has been working on. It's amazing. Thanks for having the time to talk to us.
Always my pleasure.